All right, so right now we are dealing with quotient property of powers. And in words, it says to divide powers with the same base, subtract their exponents. So if we see here with the number example, we have 4 to the 5th power over 4 to the 2nd power. And then we can change that into 4 to the 5 minus 2 power. And then that would give us 4 to the 3rd power in exponent form. Algebraically, we have a to the m power over a to the n power, and we can just subtract those two, top minus bottom, to get a to the m minus n power, and a cannot equal 0 because we are dividing by a, and we can't divide by 0. All right, so now I'm going to show you guys why this works. So I'm going to go back to the number example. So here we have 4 to the 5th power, so I can write that out as 4 times 4 times 4 times 4 times 4. And then I can put that over 4 to the 2nd power, which is 4 times 4. Now if we see, I have 5 4s on the top and 2 4s on the bottom. And if I ever have the same factor on the top or bottom, same thing that's being multiplied on the top or bottom, I can just cancel those out. So what I'm really doing is I'm basically canceling out 2 4s from the top because I have 2 on the bottom. So let's say I cancel this out, and then one more pair of 4s on the top and bottom. Now all I'm left with is just 3 4s that are being multiplied by each other, and that is equal to 4 to the 3rd power in exponent form. And that is why this property works. All right, so in this example, we have 2 to the 6th power over 2 to the 4th power, and since these two bases are the same, I can use that subtraction property that we just used in order to simplify this fraction. So I'm going to zoom in a tad, and I can just rewrite this as 2 to the top minus bottom, so 6 minus 4. And when I say that, I mean the top exponent minus the bottom exponent. So this is 6 minus 4 power. And then I can simplify this to 2 to the 2nd power, because 6 minus 4 is 2. Now, this would be our answer if we asked for exponent form or power form, but if we want this thing entirely simplified, I would just do 2 squared, which is equal to 4. So these are your 2 possible answers, depending on what the instructions say. All right, so for part B, I have the quantity, -7 to the 9th power, over, or divided by, the quantity, -7 to the 3rd power. So I can just do the same thing, because I have the same exact base. So this is equal to the quantity, -7 to the 9 minus 3rd power. And all I have to do is subtract. So in exponent form or power form, my answer would technically be -7 to the 6th power. The online textbook likes to have us leave our answer with this initial base. So that would be our initial version. But we can also simplify this into an exact answer if I wanted to plug, well, you could do it out, but I'm going to plug -7, the quantity, to the 6th power into my calculator. So I'm going to type in parentheses, -7 to the 6th power, and I get 117,649. And I actually didn't need to put that negative into the calculator, because if I'm ever taking a negative number to an even power, the negatives will cancel out and it will turn into a positive. But anyway, this is our answer, 117,649. So if it asked for our exact answer, we would put 117,649. So this is our exact answer, and this would be our answer in exponent form. All right, so for part C, I have h to the 7th power over h to the 6th power. So I can just rewrite this, because we have the same base. Doesn't matter if it's a number base or a variable base. I can rewrite this as h to the 7 minus 6 power, and 7 minus 6 is 1, so this is h to the 1st power. But h to the 1st power, that just means it's 1h, so that really is just h. So now I believe if the book asks for exponent form, you might have to put h to the 1st power, but that does simplify to h. Now for this one, because we have an h on the bottom, we actually can't allow h to be 0, because if h was 0, we'd be dividing by 0, and that would be undefined. So technically, h is not going to equal 0 here, but you don't need to worry about that for now. All right, so for this example, we are told to simplify the term 3 to the 4th power times 3 to the 2nd power all over 3 to the 3rd power. Write your answer as a power. Okay, so there's actually more than one way to do this. I'm going to show a couple right here. So the first way that I would do this is I would just simplify the top first and then simplify this fraction. So we know that if I multiply 3 to the 4th power times 3 to the 2nd power, well, these have the same base, so that means I can just add these exponents. So I can rewrite this, the top, as 3 to the 4 plus 2, because once again, same base means I can add the exponents. And then this is all over 3 to the 3rd power. Okay, so now I'm going to simplify this. 4 plus 2 is 6, so this is 3 to the 6th power over 3 to the 3rd power. And then I can use my quotient rule with exponents. We have the same base, so now that means since I have a quotient, I can subtract 6 minus 3. So this becomes 3 to the 6 minus 3rd power. And remember, when I'm doing all of these exponent property rules, the base stays the same. So anyway, now I have 3 to the 6 minus 3, which is 3 to the 3rd power, and this is our answer in exponent form as a power. We could have done this out, but we don't have to because the instructions say write your answer as a power. Another way I could have done this is I could have simplified one of these factors on the top with the bottom first, and then multiply that out. So I'm actually going to do that over here. So I have 3 to the 4th times 3 to the 2nd over 3 to the 3rd again. And now what I'm going to do is I'm going to do the quotient rule with this 3 to the 4th and this 3 to the 3rd. So this is really going to be 3 to the 4 minus 3 and then times 3 to the 2nd, because we're dividing by 3 to the 4th, or we're dividing 3 to the 4th by 3 to the 3rd, I can just use this subtraction here. And I could have done this over here too, but I'm choosing to do 3 to the 4th minus 3 to the 3rd right here, or 3 to the 4 minus 3 right here. So anyway, I'm going to simplify this. This becomes 3 to the 1 times 3 to the 2. Now you could simplify 3 to the 1 to just 3, but since I still have to multiply by 3 to the 2, it's actually more helpful to keep this 1 here. So this becomes, I'll write this underneath, 3 to the 1 plus 2, which is just 3 to the 3rd power again. So either way will work for this example. All right, so for the next one like this, we have variables, and I'm just going to do this one way, but you can do it any way you want. So what I'm going to do is I'm going to multiply the top two factors first. So I have m to the 8 times m to the 6, which equals m to the 8 plus 6, and then that's all over m to the 5th power. And then when I add 8 plus 6, I get 14, so I get m to the 14th power over m to the 5th power. But now since I have the same base on the top and bottom, I can subtract these exponents and keep the base. So I get m equals 14 minus 5, and 14 minus 5 is 9, so I get m to the 9th power, and I can't simplify this anymore, so this is my final answer. All right, so for these next examples, we're multiplying fractions together that every part of each fraction has some sort of power, and they all have the same base. So there's actually lots of ways to do this. I'll go over 2 ways to go over the first one and then just 1 for the second one. So as I zoom in here, we have the quantity -4 to the 9th over the quantity -4 to the 5th times the fraction the quantity -4 to the 8th over the quantity -4 squared. So the first thing I'm going to do the first way I'm going to do it is I'm going to subtract the exponents here first and then multiply. Okay. So right here, this fraction will turn into 9 minus 5 as our exponent with -4. So this becomes the quantity -4 to the 9 minus 5. And then that's going to be multiplied by, right here, where I have 8 on the top and 2 on the bottom for my exponent. So it's going to be -4 the 8 minus 2. Well, 9 minus 5 is 4, so this becomes negative 4 to the 4th. And then 8 minus 2 is 6, so this becomes negative 4 to the 6th power. And then I'm just multiplying two numbers that have different exponents with the same base. So since they have the same base, I can add them. So this becomes the quantity negative 4 to the 10th power. So this is my answer in exponent form, okay? But we can also multiply this out to find our exact answer, and I'm going to do that on the calculator. So I'm going to type it in exactly as we have it, but we have another negative to an even power, so I could have typed in just 4 to the 10th, and I get 1,048,576. So this would be our exact answer, and this would be our answer. So this is our exact answer. This is our answer in exponent form. Now I'm actually just going to do the other way for part B instead of doing part A and wasting people's time. So, so right here, instead of dividing the fractions first, I'm going to multiply the tops of the fractions, multiply the bottoms of the fractions, and then I'm going to subtract their exponents. So the way that looks like is I have a to the 10th times a to the 7th. So when I'm multiplying fractions, I can just multiply the tops and multiply the bottoms. So this would become a to the 10 plus 7, because they have the same base, and then over a to the 6 plus 4. And then this becomes a to the 17th over a to the 10th. And now, since I have a fraction with the same base, I can just subtract these. So this becomes a to the 17, move this over, minus 10, and that simplifies to a to the 7th. And this is our final answer. So it doesn't matter which way you start simplifying it for either of these two examples. Once again, on the top, we simplify the fraction first and then multiply it out. On the bottom, we multiply it out first and then simplify the fraction. But either way, that is how to do both of these examples. All right, so for this example, we have a map of Tennessee and an estimated area. And the question says, the projected population of Tennessee in 2030 is about 5 times 5.9 to the 8th power. Predict the average number of people per square mile in Tennessee in 2030. Well, there's a couple of things here. First, the question is asking, predict the average number of people per square mile. So I'm going to highlight that in Tennessee. And per means division. So this word right here, per, means division. We have to divide. Okay, so we're going to divide the number of people by how many square miles they have. So we know that we need to do the number of people divided by the total square miles, and this will give us our answer. And when I say number of people, I mean total number of people, so I'm going to write that in really quick. Now, let's look at the projected total number of people. We have, it says the projected population of Tennessee is about 5 times 5.9 to the 8th power. So I can just plug in this value right here for the top of this fraction right here, because that is telling us what the projected total number of people is. So I'm going to write that in. So that's going to equal 5 times 5.9 to the 8th power. And then on the bottom of the fraction, it says we have the total square miles of Tennessee. Now, that's probably not going to change anytime soon, so we're going to just assume that we can use the current value of their square miles for their area. So I can just plug in this value right here, 5.9 to the 6th power, into the total number of square miles. And that's going to give me, on the bottom of this fraction, 5.9 to the 6th power. So really, I just need to simplify this fraction. So I'm going to zoom in a tad. we can use our quotient exponent property. I have the same base for the 5.9 on the top and the 5.9 on the bottom. So what I can do is I can subtract these exponents. So at first I'm just going to do, I'm going to take care of this division, and then I'll care about this times 5 over here after. So this is going to become 5 times, and then the quantity. You don't really need parentheses here, but you can have them if you want. So now I'm going to do 8 minus 6, because it's always top minus bottom in this case. And now I can simplify 8 minus 6, and that's going to be 5 times. Here I won't write parentheses because we definitely don't need them. You can always have them though. So 5 times 5.9 to the second power, because 8 minus 6 is 2. And now I just have to evaluate what this is. So I could multiply this out, but I'm just going to use my calculator and plug this all in to get 5 times 5.9 squared. So I'm going to type that exact expression into my scientific calculator. 5 times 5.9 squared. And since I typed it in like this, and this calculator does order of operations for me, this is fine. But if you're going to use a calculator that isn't as advanced as this, you would calculate 5.9 squared first and then multiply the 5. But anyway, this answer is 174.05. So I'm going to write that down. So that is our exact answer here. But if I go back and look at what it is telling us, we're just predicting the average number of people. So we probably don't need this 0.5 on for our decimal, because we have a pretty close to a whole number anyway. So what we can say is that the average number of people per square mile is going to be about 174. So our exact value is going to be 174. But anytime we have a word problem, it's nice to have a word answer. So I'm going to type in here the average population in Tennessee in 2030 will be about 174 people per square mile. So this is the correct value, and now we've answered the question with a word answer. So that's how to do this one.